Hello friends, this is Lakshmipati and I am from MECP. Today in our material science class we are going to discuss about the topic called heat treatment of steels. Heat treatment is a process involving heating and cooling operation applied to a material to modify the internal structure and physical, mechanical and chemical properties of material. Heat treatment methods are applied in order to strengthen the metal. The temperature and time of heating are strictly controlled as it has effect on grain size. After hitting the designed temperature, the metal is cooled at a specified rate. And here are the stages of the heat treatment process that heating a metal alloy to definite temperatures, holding the metal at the temperature for a sufficient period and allowing it to occur the necessary changes. Cooling to obtain the design properties like ferrite, pearlite, martensite. And here is the principle of heat treatment. And in the principle that is nothing but after applying the heat, the existing structure and properties of steel will be converted into different structures and later on, different structures and later on after cooling they will obtain the desired properties and the cooling processes are classified depending upon the rate of cooling. If it is a very slow cooling it is called annealing, and if it is a slow cooling it is called normalizing. If it is a rapid cooling it is called hardening. And here are the various heating sources. We can have oils, salt baths, furnaces, etc. Cooling media and are the brine solutions, cold water, water plus soluble oil, air sometimes, in which the normalizing we will just leave the material in the air. And the objective of heat treatment process is to relieve the internal stresses, refine the grain size to improve the mechanical properties, improve machinability, harden and strengthen the metal, improve electrical and mechanical properties, improve wear resistance, improve corrosion resistance. And here is the classification of the heat treatment process. The heat treatments are classified as bulk and surface or case hardenings. In bulk, it is classified as annealing, normalizing, hardening, and tempering. And these classifications are depending upon the various, the time requiring or the rate of cooling the heated material. In annealing, it is further classified into full annealing, process annealing, spheroidized annealing, and tempering. It is classified into low tempering, medium tempering, high tempering, os tempering, and matte tempering. And the surface or case hardness, in which is it is the second case in the heat treatment process, and it is classified into diffusion process, thermal process. The diffusion process have subtypes like carbonizing process, nitriding process, cyaniding, and carbonizing. The thermal process is like flame and induction hardening. And case depth. What is case depth? The depth or the thickness obtained on the specimen after heat treating, called as case depth or case thickness. Surface of this workpiece will be hardened. It is the effective portion of the material which will be hardened after the heat treatment process. And the entire change in the structure and properties can be effectively seen in this region only, and this region is called as case depth. So let's go to the topic called annealing. It is the process of heating the metal to a suitable temperature and slow cooling inside the furnace itself. As a result of slow cooling, the metal occurs an equilibrium structure which causes the following: to relieve the internal stresses, reduce hardness, improve ductility, to refine grain size, to produce a definite uniform ductile coarse grain microstructure. Applications of annealing is castings, forging, pressworks, etc. And annealing, there are types of annealing like full annealing, process annealings, and here is about the full annealing. It is mostly suitable for hypoeutectoid steels and the steels containing less than 0.7 percentage of carbon, which are heated up to 723 degrees to 910 degrees. This is done to obtain the austenitic structure and temperature is maintained for a period of time. Cooling is done in furnace by decreasing the temperature 10 degrees to 30 degrees centigrades per hour. The specimen is removed from the furnace and air cooled to the room temperature. Structure of pearlite is obtained which has uniform medium coarse grain size which is soft and ductile in nature. And for hypoeutectoid steels, which is mostly suitable for materials with this greater than 0.7 percentage of carbon. The heat treatment is done between 723 degrees centigrades to 1138 degrees centigrades. Structure will be coarse perlite in nature. Objectives of this full annealing is soften the material, refining crystalline structures, reduce hardness, relieve internal stresses, improve machinability, improve ductility. And the next type is the process annealing, which is mostly suitable for low carbon steels. It is heat treatment process used to soften and increase the ductility. The material or metal is heated between 650 degrees centigrades to 750 degrees centigrades, held for a period of time to achieve softening. Later, they are cooled. This process leads to the recrystallization which leads to the improved ductility, softness, free from internal stresses. The bow heat treatment results in hardness, reduction, and increase in percentage of elongation. Applications are a sheet for manufacturing or the common applications. And our next type in the annealing is the stress relief annealing, employed to eliminate the internal residual stresses induced by previous strain hardening metals. Cold working process. The strain hardening is nothing but the cold working process in which the metal will be processed below the raw crystallization temperature, mostly to obtain a specific shapes and sizes. So, this stress relief annealing is done to relieve the stresses induced during the cold working processes, which are done to the castings, machining, cold working, welding, forging, rollings. Internal residual stresses are caused due to plastic deformation process, non-uniform cooling of a metal, heating and cooling of alloys made of two different metals having different densities. Effects of internal stresses. If the stresses are not removed, distortion or warpage occurs. And the operation. The alloy steels are heated to 650 degrees to 750 degrees centigrade, held for a period of time and cooled slowly. This type of treatment is called as recovery, which is the phenomena that removes internal residual stresses with little change in mechanical properties and no drastic change in microstructure. And the next type of annealing is the spheroidized annealing. High carbon steels and tool steels are mostly preferred with the spheroidized annealing. These steels are too hard and difficult to machine. The heat treatment is done between 750 degrees to 800 degrees and holding the specimen at the same temperature for several hours, like 2 to 5 hours, and cooling it inside the furnace. This causes spheroidal formation in which the cementite structure, which is hard in nature, with soft grains. Objectives of spheroidizing is to soften the hardened steel, to improve the ductility, machinability, and formability, to obtain medium hardness, strength, wear resistance. When the material is having a spheroid structure, the ductility and having a good ductility, it will also have a good property of machinability. And the next process is the normalizing, in which the material is cooled in the atmospheric air. That is a process of heating the metal and cooling the metal in the air. And the objective of normalizing is to refine the grain structure, increase the strength of the steel, non-uniform structure when compared to annealing, and the stress to remove the internal stresses and improve the machinability and ductility. And the operation or the procedure is that the steel is heated between 750 degrees to 950 degrees. It is held at this temperature for short time, like 15 to 30 minutes, allowed to cool in the air. Due to faster rate of cooling comparative to the annealing, normalized steel process fine grainer structure than annealing process. And here is a comparison table between annealing and normalizing. The grain structure is coarse when compared to normalizing process between the slow cooling process. Fine grain structure is obtained more expensive process and the normalizing is a less expensive process and more time consuming process. Annealing takes more time because the cooling rate is very much high and very much low and the time is very much high and less time taking process because it happens outside the furnace, so obviously the time taking to reduce the temperature will be comparatively less. The process is done below the 900 degrees centigrades and the process is done above 900 degrees centigrades. to relieve the internal stresses, to improve the mechanical properties. Grain distribution is more and uniform, grain distribution is less and non-uniform. Less hardness is obtained, more hardness is obtained. Comparatively to the annealing, the normalizing steel, the normalizing materials will have more hardness. And here is our first video, and we'll conclude here.